here in planetarium.
Galileo's audacious exploration of Jupiter found enough heavy hydrogen to confirm that during the first minutes of the Big Bang, the entire universe was hotter than the center of the sun. Hot enough to forge simple atoms. But while scientists were piecing together the history of atoms, evidence emerged that most of the matter in the universe isn't made of atoms at all.
Oh, I like that. Look at that, it's so pretty. Those are the stars.
The universe contains clusters of galaxies, like this one. Each cluster, home to trillions of stars, generates enough gravity to warp the space around it into a giant lens that distorts our view of the galaxies beyond. But when we calculate the strength of these gravitational lenses, we find that each cluster must contain 6 times more matter than we can see there. So now it seems that all the glowing stars are just the glittering froth on a dark cosmic ocean of invisible stuff called dark matter. The motions of galaxies within each cluster confirm the presence of dark matter. The galaxies orbit too fast to be held together by the gravity of normal matter alone. Remove the dark matter, its lensing stops, and the cluster flies apart. Scientists find that dark matter, shown here in black, was essential to forming the large-scale structure of today's universe.
Let me know if we stay here, okay? I'll be going out, okay?
This computer simulation traces how cosmic structure evolved over time. The bright knots contain thousands of galaxies, drawn together by the vast sheets and tendrils of dark matter. These knots grew from the densest regions seen in the cosmic background radiation. The less dense regions of the background became cosmic voids, big, empty bubbles, hundreds of millions of light years wide. The gravity generated by normal matter is much too weak to create this cosmic web. Dark matter must be doing the job. What is dark matter?
There you go, there's the Earth there, and the satellite. That's the satellite.
Scientists are conducting experiments to find out. Some of their detectors are buried deep beneath Earth's surface to minimize interference.
It's really close, right? Oh my gosh, that's so pretty.
One detector, mounted on the International Space Station, looks for signs of dark matter particles interacting far across the galaxy. While scientists expect that dark matter particles may soon be found, another mystery has emerged that's changing how we think about the future of our universe. Astronomers had thought that the gravity exerted by all the matter in the universe would slow down the rate of cosmic expansion. To check this prediction, teams of observers charted the distances and speeds of extremely remote galaxies by studying exploding stars called supernovas. As this time-lapse view of the Milky Way shows, stars explode fairly often at a rate of about 2 per century in a galaxy like ours. So, if you observe enough galaxies, you can spot a new supernova every few nights. The observers were especially interested in a particular type of supernova,
Whoa.
like this one, where the corpses of two dead stars orbit each other so closely that they eventually collide and detonate.
Whoa. Whoa.
Such supernovas are very bright and consistent in brightness, providing scientists with an extraordinary tool for measuring cosmic distances across the universe and back through time. By measuring the distances and speeds of hundreds of supernovas, the astronomers learned how fast the universe was expanding billions of years ago. By 1998, to their astonishment, they found that the universe hadn't expanded faster in the past as expected. Just the opposite. It used to expand more slowly than it does today. The expansion rate isn't slowing down, it's speeding up, accelerating. And it's been accelerating for the past 5 billion years. The pressure causing the acceleration is called dark energy. But that's just a label. Nobody yet understands dark energy, though it appears to be powerful enough to shape the course of cosmic destiny. Normal matter, all that we are, or all that we've ever seen or touched, amounts to less than 5% of the known universe. So we know precisely when the universe began, and we're beginning to understand what it's made of. But how big is it? Our observable universe is limited to the part of the cosmos from which light has reached us here on Earth. But every galaxy occupies the center of its own observable universe. Observers in this distant galaxy can see light from regions we cannot yet see. And we can see regions they cannot see. So no matter who or where you are, you'll reach the same conclusion, that the universe as a whole must be bigger than the part of it you can perceive. How much bigger? Some scientists speculate that if the observable universe were the size of a planetarium dome, the entire universe would be larger than planet Earth. Others suggest it may be infinitely large. Clearly, there's more to the universe than meets the eye.
There you go.
The Big Bang happened long ago, but not far away. It happened here, there,
Everywhere.
and everywhere. Peering into the dark, we stand on the threshold of great discoveries. And we always will,
Earth.
as long as we keep exploring.